Hi everyone, thanks for checking out this video. So in the last video, I was telling you guys a bit about parameter estimation, and I gave the example of linear regression and solving for the parameters m and b as being like one example of parameter estimation that we could use to like build intuition. And just to quickly review, if we have some model like a linear model y equals mx plus b, the residuals are the difference between our model's predicted y values for some x and the actual y value for that x in the data. So the residuals are just like a measure of how far off our model is, and when you square them and then sum them up, that's what's called the least squares loss function, which is basically like a way of quantifying the overall inaccuracy of the model. So then the idea with parameter estimation is you want to try to search for the parameter set of m and b that minimizes that loss function and like minimizes the model's overall inaccuracy. Yes, that was what the last video was about. So this video, I'm gonna be showing you guys how to actually implement this in Python and how to use Python to basically fit a line to data from scratch, just as like a practice for this idea of parameter estimation. Okay, so I made up a fake data set. This is a data set I made up just by like using a linear function y equals mx plus b and plotting it for a bunch of x's and y's and adding noise into the function. So basically just for every y value, I just plotted it as a function of x and then added or subtracted some random number to give it some noise. And so this is basketball skills as a function of height. So I have the height here in inches, and then the vertical axis is some like measure of basketball skills. And I kind of made this as like a joke. Like I don't think that like basketball skills actually like scales like perfectly linearly to height, but this is just kind of an example data set I made up just so we can get some practice like fitting a line to this data set. And you guys might also notice I also included myself in this data set too. So if you see this outlier dot like way down here, that's me in this data set. So I just include myself in this data set as an outlier because I'm 72 inches tall and really, really bad at basketball. So I used to actually play basketball when I was a kid and was just like really bad at it, and I'm still bad. So this dot here, this outlier in this data set, is me. So just include myself in there. But okay, and yeah, so we're gonna try to like basically figure out just by parameter estimation what m and b values were used to generate this data. And at the end of the video, I'll tell you guys, I'll like actually reveal what the true m and b values were that I used to generate the data, and we can see like how close we get in trying to figure them out. But yeah, here's the CSV of all these data points. So we just have in the first column, it's the height in inches, and then the second column is some measure of the basketball skills for each of these points. Okay, and so let's just get started. So the first thing we do, as always, is just import the libraries we're going to be using. So just kind of the usual ones like matplotlib, numpy. We're going to need the random library this time, the CSV library, and then scipy.optimize. If you guys don't have this yet, you can download it. This command here, pip3. Just pip3 install scipy to get that installed. But yeah, so those are the libraries we're going to be using. And then, so the first thing we need to do is import all of this CSV data into our program. So I'm actually just going to be a bit lazy here and just copy and paste some code to do this part. But I'll explain like what the code's doing. But I'm just going to copy and paste this from another file for now. So we're going to be recording our heights and the skill levels for each of these dots. Basically, for each row in the CSV, we're just recording the height and the corresponding skill level. So we're going to be just using, just opening up the CSV file with this line here. We're going to be defining our reader, the CSV reader, using the CSV library. Calling this file, by the way, and then passing the file in here. and then choosing comma as the delimiter because it's a CSV, so there's commas separating the columns from each other. And then so this line here is basically just skipping the header. It's just next reader. That's just skipping over the first line because the first line is just the names of the columns. So we want to just skip over that. And then I just said for row in reader, just going through all of the rows, we're going to be appending to our heights list the float of the first column in that row, and to our skills list we're going to append the float of the second column. And we need to cast these into floats here because if we try to just append the first element of the row, that's going to be read in as a string. So we need to like manually cast it into a float here, or else we're going to be getting strings in these arrays. So at this point, we should have read in all of our heights and the corresponding skill levels into these lists here. So then the next thing we're going to think about doing is writing our loss function. So it's kind of like I've been saying, the whole point of parameter estimation is that you have some loss function that measures, like, for a given parameter set, the inaccuracy of your model compared to the data. So basically, like, the loss function is a function of the parameter set, and it's just like saying, okay, for this parameter set, this is how inaccurate the model was compared to the data. Okay, so we're going to just say define loss function. The argument's going to be params, heights, and skills. Okay. So then the params, this is going to be actually a list with both of our params in it. So we're just going to say, and this will make more sense when we start actually like calling this function. But the first element of this params list is going to be our parameter m, and then the second element is going to be our parameter b. Okay. And the loss is going to start out at 0. So we're going to start off just saying loss is 0 to start with. And then, okay, here's the important and interesting part. So we're going to go through all of the data and then basically compare our model prediction for these params, compare it to the actual data, and then see what the difference is. So the way we're going to do this is we're going to iterate through the heights and skills lists at the same time. So we're going to say for I in range length heights. And remember, they have the same length. Heights and skills have the same length because for every height, there's a corresponding skill level. So this will give us an I that we can use in both of these lists here. So then we're going to say, we want to see what our predicted skill is. So the predicted skill, it's going to be our m times that height plus b. So this is just our linear model here. We have our m param and our b param, and it's just y equals mx plus b, except our height that we're looking at from the data is our x, and then the y we're getting out of this is our predicted skill level. So this is just seeing, like, okay, so for this height in the data, what would our model with these parameters predict would be the corresponding skill level. So this is just getting like our prediction for the y that we're going to compare to the actual y from the data. So that's our predicted skill level, and then of course the actual skill level in the data for this height is just going to be skills I, right? Because for every height there's a corresponding skill level in the data. So at index I, the corresponding skill level is just skills I. But the way we're going to get the residual is we're going to say res equals predicted skills minus skills I. So it's basically our prediction, our predicted y minus the actual y in the data. Predicted skills minus the actual skill corresponding to that height. Squared, because remember, we're squaring all of them because the residual could be negative, so we want to square all of them to get them all to be positive. And then we're just going to update our loss and just basically add up all these squared residuals and just update our loss to just add on this this residual. So we're just going to go through that. This is basically just going through all of the rows of data and seeing for some parameter set that we're passing in how well our prediction does compared to the actual data. Yeah, so at the end, of course, we return the loss. Okay, so this is really all we need for our loss function, and then the challenge here is going to be to search through the parameter space of like possible m's and b's and like sets of m and b, and just see which parameter set will minimize this loss function, because that will basically mean like we're looking for some parameter set that will do the best job of having this linear model fit the data. That's really the idea of all this. So I'm going to show you guys how to do this like from scratch. But before we do that, I'll just show you guys kind of the easy way to use a regular Python function to kind of easily do it for you. So I'm actually just going to copy and paste this part into. Sorry, being a little bit lazy here, but yeah, just before we actually do it from scratch, which will be kind of the interesting part, I'll show you guys like the easy way to do it. Just having like Python just do it for you. And that's using this scipy.optimize.fmin function. So I'll show you guys in a second like what each of these things are, what everything means here. Actually, I should just I'm going to rename this to make it less confusing. Because yeah, it's not really x. It should be this is like the starting parameter set that we're using to test first, and then basically this is just minimizing whatever function we tell it to minimize. We're telling it to minimize the loss function, and then this param 0. This is just our parameter set we're starting with, and then we're passing in heights and skills as the arguments here, and just I'll just make a note here. This is just M and B, this parameter set. Yeah, pass in heights and skills. These lists will just be args in this function, and then this is basically just going to minimize this loss function we've defined using heights and skills as args that are being passed in, and search for the parameters M and B that minimize this this loss function. And this is just kind of like an easy way to just use a Python library to do it for you. So before we do it ourselves, I'll just show you guys like what the output for this is. Okay, so this basically said that it solved for these params that minimize this loss function, and it basically predicted that the m value would be 1.9 something something, and that the b value would be 11 point something something. Interesting prediction. I'm not going to show you guys the actual true underlying m and b values until the end of the video because next we're going to do it ourselves from scratch and see what we come up with. But yeah, this is what this fmin function. This is the parameter set it came up with, was like 1.9 for m and 11 point something for b. So that's just the parameter set it came up with to minimize this loss function. So interesting. We'll see at the end how close it got. But before I show you guys the true values, I'm gonna show you guys how to do this from scratch, because even though we have these built-in Python functions that we can just use to do it for us, I think the way to really build intuition is to do some of this stuff from scratch, so that we really see what's happening in every step. You know what I mean? So we can really better understand what's going on. So yeah, now I'm going to just show you guys how to do it from scratch. So I'm just going to show you guys kind of the easy, non-elegant, brute force way just for now. Although in future videos, I'm probably going to make some more videos on how to do it more elegantly and more efficiently. But for now, the strategy for searching through the parameter space is basically just going to be that we're going to randomly try a bunch of parameter sets, just randomly pick possible values of m and b, and evaluate our loss function at those values. And then just do this a bunch of times, a bunch of iterations, and keep track of what our lowest loss was and what the parameters were for the lowest loss. So we're just gonna make a huge for loop. So we're just gonna say for counter in range Yeah, like 100,000. Just give it like a lot of iterations to try to get some good results here. Yeah, so we're just gonna iterate through this a bunch of times, and then we're gonna pick a random value for m and b to test out. So we're just gonna say test m equals random dot uniform. And so we kind of know that we're not looking for a negative slope. Like we know the slope is going to be positive, and you know what I mean? Like we can rule out some things just visually. Like we know we're not looking for like a negative slope here. So I'm just going to say like the test m that we're randomly choosing will be somewhere between 0 and 20. And this random.uniform will just give us a random number that could be a decimal, could be a float, somewhere between 0 and 20. So that'll be our m that we're testing. And then same thing for b. Random.uniform. This one, we can almost see what the b is just by looking at it, but I don't want to make this too easy. I don't want to make it too easy for our program, so I'm gonna give it some range. I'm gonna say the b could be anywhere between negative 100 and 100, just to give it some parameter space it actually has to search through, rather than just like visually figuring it out. You know what I mean? So yeah, basically here we're just picking a test m and a test b. We're just randomly picking them. And then we're going to just store those. Just call it like current params equals just get them organized, put them in this params list here, and then we're just going to like find out what our loss is for this random parameter set we just generated. So we'll say current loss equals loss function, passing in the current params, and then the heights and skills. So basically, we're just seeing like, okay, what is our loss for this random parameter set we just picked? And again, I know I'm just saying the same thing again and again, but the loss function is just a measure of the inaccuracy of the model for some given parameter set, like how inaccurate it is at explaining the data for some parameter set. And that's why we're trying to find the parameter set that minimizes it, because that will be the parameter set that most closely allows our model to match the data. Okay, so we have our current params and current loss. And then, okay, so this is going to be the part where we want to keep track of what the best loss we found is so far, meaning the lowest loss. So we want to keep track of that. So we're going to say if counter is 0, if it's our first iteration through this, then we're just going to save whatever we have. So then we're going to say best loss equals current loss, and best params equals current params. So that's just saying like the first time through this for loop, we're just saving whatever we come up with. But then every time coming through the for loop after that, we want to check if our current loss is actually like the best one we've had so far, meaning the lowest one we've had so far. So we're going to say if it's not the first iteration, every subsequent iteration, we're going to say if current loss is less than our best loss, then we're going to say we're going to update the best loss to be the current loss, and then update the best params to be the current params. So again, just to iterate, and this is like a super like non-elegant way of doing this. In future videos, I'll show you guys like more clever and like more elegant ways of like searching through the parameter space. But just to like reiterate again here, we're just having this huge for loop, a bunch of iterations, and for each one generating a random m and b in some range that we think is feasible. And for b, actually give it like kind of like a wide search space, just to not make it too easy. And then we're just seeing what our loss is for those params. And then if the loss is the lowest one we've seen so far, then we're keeping track of it. We're recording what the loss was and what the params were that had that loss. Okay, yeah. So this is really all we need for that. So then we're going to print out the best loss, and we can also print the best params. And then, so the last thing we want to do is taking our predicted params. We want to actually plot that line against plot it like on top of our data, and then see just what it looks like visually if it seems to be a good fit. Oh yeah, but first just want to say, yeah, I'll just call it mfit equals best params first element, and then bfit equals best params the second element. So these will be our predicted values for M and B. And then yeah, I'm just gonna be a bit lazy and just copy and paste in some code to like actually plot what the line would look like with these estimated values. Okay, so this should hopefully be good. I think this is going to take a long time to run, so I might just skip ahead in the video. Okay, so now we have some results. So these are the parameter estimations that our code came up with. So for M, we have the estimate of, again, 1.9 something something, and then for B, it was 10.98 something something, so about 11. So these are the M and B estimates from this code we just run. And then so we've also plotted the line fit here too. So this red line is the line we came up with based on our estimated M and B parameters. So yeah, it looks like it's kind of a pretty decent fit, I would say. And so yeah, so I guess now's the moment of truth where I'll show you guys like what parameters I actually used. So to generate this data, I used M equals 2 and B equals 10. So yeah, pretty close to our predictions. We predicted M as being like 1.98 something something, and then B as being like about 11. So it was a little bit off there, but not so off. And again, we also like made it like a little bit harder for ourselves than it had to be, because even though we can see that like B is like definitely positive, we kind of gave it like a large search space for B to give it some challenge too. And again, like I also wrote this in a pretty like inefficient and like non-elegant way. So in future videos, I might show you guys some like better techniques for like moving through this parameter space and like searching for the minimum of it. So yeah, that's all I have for you guys for this video. Like usual, I'll put the code and stuff up on my GitHub, and I'll link to that in the description if you guys want to download it. And just if you have any questions, let me know in the comments. And thanks for watching, and see you next time.